Okay, let's do this again. Get it ready. Okay, backing up. Oh, fuck me. Harman Kardon AVR161. Apparently it doesn't turn on. Let's have a look. It's a bit big. Yeah, taking up all the space, yeah. Plug it in over here. Plug it in. Anything? Nothing. No lights. Power button does nothing. I should be able to get this lid off. Sorry. Whoops. Too much stuff on the bench. First things first. Cover looks fine. Just the usual overspray. All good. No remnants of an explosion. We're going to be working on the power supply side. I'm fairly certain on that. I don't really want to stick my hand in there because capacitors. But the fuse is blown, so the best set of tools is a dental set. Awesome for electronics. Why did the fuse blow? It's a beefy boy. T6.3A H 250 volt, 6.3 amps. That does appear to be a blown fuse. Okay. Do I have any? Do I have any fuses? These are going to be 2 amp or so. F2AL. I suppose we can always use one of these to just test. Alright, let's try with the 2. Oh, you awkward fuck. Oh, perfect. Perfect. You really want me to reach down there, don't you? Two amp. Will it go boom? No, my power cord isn't. Is it? It's not long enough. We're gonna get this in the picture still. We're gonna get it in frame. So this might just happen quickly. So I'm backing up, putting it in. Oh. Okay, let's do this again. Get it ready. Okay, backing up. Oh, fuck me. Okay. Oh, we have a short. We have a short over here. We have a short. Right, so I've taken the board out of the machine, the power supply, out of the amp. And done just a little bit of troubleshooting and have found that we have a short across one of our big caps. That's like a dead short. So I'm going to remove that cap, that big fatty, and then we're going to test. I doubt it's the cap. Okay, so let's remove this cap, this fat one. I'm going to change this tip to something wider. $350 degrees. Oh, look at that. I found the service manual. And it's got every single part listed. It's amazing. Amazing. A little bit of flux. Let's find some solder that's lying around here. Here's a piece. Gonna dump some leaded solder just to soften up the lead solder. And it's going to be a bit of a challenge because it's so big. So we're going to have to rock it out slowly. Oh, never mind. There it is. Let's just make sure that we know, okay, the tape is going to show which orientation, but negative towards the side of the board. Oh, we've got a mark on there. Okay. Don't think it's the cap. Okay. That's interesting. What is this? Oh, it's a leg for that MOSFET. I wonder if this MOSFET's fine. But that could be the short that we're getting somewhere. So it's going to take some time. I'm going to have to remove components and check. And we figured out that we have a short coming from or between the rectifier out and this ground plane. This is the rectifier here. We have our live and neutral. Then we have our positive and negative. I'm guessing this is the negative side. I'm going to jump on the other side of the board to this side. I wonder if this rectifier is fucked. It doesn't look fucked. I was thinking of taking it out. So our short is between these two. I'm going to remove the rectifier and we'll take it from there. So I don't know. I don't think it's the rectifier. Let's see. Nope. Dead short. So we know we have no short on this input. We're good. It's on the rectifier side. After the rectifier. So those are jumpers. We have... Okay, I'm probably going to have to take this heat sink off. Alright. Do we still have a short? I have to remove the mosfet. We don't. Do we have a shorted mosfet? We may have a shorted MOSFET. I'm going to put the rectifier back in. Okay, no short. Looks like our short is the MOSFET. Okay, capacitance. Awkward. I mean, no. Oh, the battery's died on this thing. 11.9 nanofarads? No way. What? Is this cap fucked? 450 volt, 120 UF. That is concerning. Dude. Let's measure with this thing quickly. We have capacitance here as well. Oh no, that's diode. 13.26 nanofarads. Alright, so I just want to test this quickly. I've taken it off that heatsink. Looks fine, but the short went away when that was removed. So let's do continuity. .9 ohm. 5.9 ohm. 0.1 ohm. 5.9. 5.9, 0.1. It's definitely shorted, and it shows zero signs of it. Normally these things blow when they go short. Okay, let's do a quick resistance, just to get a better number. Zero 0.11 ohm. 5.97 ohm. Yep, that's done. While we're here, let's check the internal resistance of this cap. It overloads on 100 mega ohm. Yeah, I see it go like 110 meg and then it overloads 117 meg. That's quite a bit. Alright, both of these parts are done. I did a little bit of work off camera. What I've done is replace a few parts. I'll show you which now. And how many do we have here? 1, 2, 3, 4, 5, 6. So 5 caps. And then the N-channel MOSFET. Alright, so this MOSFET looks fine, but it's dead short. I think the spec on this one is 650 volt at 39 amp, if I remember correctly. And it's been replaced with, this is an Infineon chip, by the way. I've replaced it with an onsemi. This is a 600 volt 80 amp, so double the amperage. And in terms of caps, I did get a 450 volt 120 microfarad cap, but I'm not going to be going with this one because it's only rated at 85 degrees Celsius. Unfortunately, it's a decent cap. It's a Rubicon, but because it's only 85 degrees, I'm not going to go with this one. I'm going to put it in now for testing, but this one's going to come out in the next few days when I receive the 105 degree rated cap. It's quite important because this is in a amplifier and it is on the power supply circuit and it's sitting right next to a heatsink. So it will take heat, and the higher the rating, the longer the lifespan. So it doesn't necessarily have to get to 85 or 105 degrees, but if I put this 85 degree cap in and let's say it's running at 65 degrees, it's going to be, you know, a lot shorter lifespan as opposed to something that's tolerant for, you know, 105 degrees Celsius, and if that's running at 60 or 65 or whatever, you know, there's a lot of headroom there, so, you know, lifespan is affected by this. So the other caps that have been replaced are these Acon brand. Never seen these before, but these did have, you know, they were slightly down on the microfarads, and the internal resistance, you know, while it wasn't high, it wasn't great. So these have all been replaced as well. So on the board, our N-channel MOSFET slightly moved down on the heatsink just to accommodate for slightly shorter pins, a difference of about 5 mils. So I had to move it slightly down, but it is on and it's tight. Okay, obviously I haven't put the big cap in yet. It goes right there. Then caps that have been replaced is this, I think it's a 47U, is it? No. Yes, it is. So we have a 47U cap over here. Here we have a 22, no, is it? 22 UF 50 volt, 10 UF 50 volt, and then we have, and I think this is a 22, yeah, 22 microfarad, 450 volt. That's a Rubicon cap, and that's been replaced. We can get this in to test it. Yeah, we might as well do that. This one's a bit smaller than the original, but it doesn't really matter. $350 degrees. This is a ground plane. It's going to take some time to flow everywhere. All I want to do is just push on the cap and melt it. Make sure that the cap is sitting flat. And there we go. Continuity. So before we had our short on the rectifier output, so the input nothing, output we have 400 ohm, so that's fine. 410 ohm. So we don't have the dead short or anywhere near short. So I think we can apply power and test. Okay, I'm gonna have to move this over. Okay, we should be fine. I did my tests. We can probably test with a multimeter. Okay. I'm probably not going to get anything because it needs to be turned on. Yeah. All right. I must just keep in mind that that cap is going to be full of energy when it comes time to change it, and it's going to have to be discharged. Alright, we have a light on the front. Is that even going to be visible? It is. I don't really want to put it down on the power cord. Can we do it at an angle? There we go. Auxiliary. Volume at -80, and it was on -10. Oh, were they cranking it when this went down? I think they were. Maybe. Plus 9 dB, and it said -10. But it goes to -80. I just want to change that capacitor to the proper temperature rated one. I've received the caps, so we're going to proceed to change them. But I just need to be careful taking this out. We're going to replace the Rubicon with this Nishikon 105 degree. I'm going to change the smaller Rubicon 22 UF 450 with another Rubicon 22 UF 450 105 degree. I'm going to change, I think it's this 10 UF. This was an 85, but I've got 130 degree, so we're going to put that in. And the Nishikon that I've already installed over here is a 105 degree, and then this one here we will double check. Okay, all of our caps are in, all the negatives are facing away from me. Now we have to glue all of these down. Last cap, and then we are done. There we go. A little trick for screws that aren't magnetic. Are these? No. It's a tiny bit of press stick. I think in the States it's called blue tack. So you can basically drop your screw in without it disappearing into the abyss. Okay, that's nice and tight, that's tight, that's good, 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 good. Temperature sensor, everything is in place. Okay, one more time, let's turn this on, and then it's going to get a quick clean and get ready to go back. Very nice. Okay, there we go. Another one.